In today's lecture, we'll be learning about square relations. So first formula is sin square theta plus cos square theta is equals to 1. The second one is sec square theta is equals to 1 plus tan square theta, and third one is cosec square theta is equals to 1 plus cot square theta. Okay, let's prove one of them. Prove that sin square theta plus cos square theta is equals to 1. In solution, let's say we take left hand side. So left hand side is equals to sin square theta plus cos square theta. Now sin theta is perpendicular by hypotenuse whole square, plus cos theta is base by hypotenuse and cos square theta, so whole square. So this is equals to p square by h square plus p square by h square. So we get p square plus b square by h square. And p square by b square, perpendicular square plus b square, is hypotenuse square, as p square plus b square is equals to h square by Pythagoras' theorem. So which is equals to 1, that is right hand side. So hence the proof. In the same way, you can take a right hand side for both of them and show that they are equals to the left hand side. Okay, let's begin with some examples. This exercise particularly now that we'll be dealing with will mostly be proof based. You need to take one side, or you may need to take both the sides sometimes and need to prove the other is true. So example, say number 1. Cosec theta minus cot theta whole square is equals to 1 minus cos theta by 1 plus cos theta. Okay, here we can work with left hand side as well as we can work with right hand side. So let's say we take left hand side and work with it. Solution: left hand side is equals to cosec theta minus cot theta whole square. So this is equals to, cosec is 1 by sin theta, or 1 by sin theta, minus cot is cos theta by sin theta whole square. So this is equals to 1 minus cos theta whole square by sin square theta, or this is 1 minus cos theta by sin theta whole square. So this is equals to 1 minus cos theta whole square by sin square theta. Now sin square theta plus cos square theta is 1. So sin square theta will become 1 minus cos square theta. So this is 1 minus cos theta whole square by 1 minus cos square theta. So a square minus b square, 1 we can write as 1 square. So a square minus b square is a plus b, a minus b. So this becomes 1 plus cos theta into 1 minus cos theta. 1 minus cos theta and the square cancels off because the numerator also has 1 minus cos theta. So this is equals to 1 minus cos theta by 1 plus cos theta, that is equals to the right hand side. Hence the proof. Okay. in this same question, you could have taken the right hand side and gone backwards in the same manner. You would have gotten the same solution. Second example. Cos A by 1 plus sin A is equals to plus 1 plus sin A by cos A is equals to 2 sec A. Solution. In this type of question, as we can clearly see that the right hand side is just this one, but in the left hand side we have much more work to do. So we'll choose the side in which we need to do more work. We'll take left hand side and solve this question. So LHS equals to cos A by 1 plus sin A plus 1 plus sin A by cos A. This is equals to, when we take the LCM is 1 plus sin A into cos A. Cos A multiplies over here, cos square A. 1 plus sin A multiplies over there, 1 plus sin A whole square. So this is equals to cos square A plus 1 plus sin A whole square is 1 plus 2 sin A plus sin square A by 1 plus sin A into cos A. Now over here, cos square A and sin square A, the addition of this is 1. Sin square theta plus cos square theta is 1. So if the theta is A, angle is A, cos square A plus sin square A is 1. So 1 plus 1 plus 2 sin A by 1 plus sin A into cos A. This is equals to 2 plus 2 sin A by 1 plus sin A into cos A. So this is equals to 2 comes common, 1 plus sin A by 1 plus sin A into cos A. 1 plus sin A, 1 plus sin A cancels off. 1 by cos A, by reciprocal formula, 1 by cos A becomes sec A. So this is equals to 2 sec A. That is equals to our right hand side. So here's the proof. Okay, for every question you can have multiple ways of solving them. Let's see another way of solving this particular question. See, again we choose left hand side. Left hand side equals to cos A plus 1 plus sin A by cos A by 1 plus sin A. The more you try to visualize things in trigonometry, the more methods you can find on your own as well. So let's say we are multiplying and dividing with 1 minus sin A with just this term. So if we multiply and divide with 1 minus sin A plus 1 plus cos A by 1 plus sin A by cos A, this is sin A by cos A. So this is equals to cos A in brackets 1 minus sin A by 1 plus sin A into 1 minus sin A is 1 minus sin square A plus 1 plus sin A by cos A. This is equals to cos A 1 minus sin A by 1 minus sin square A becomes cos square A, because sin square theta plus cos square theta is 1. So 1 minus sin square theta is cos square theta. So this square and this cos A cancels off, plus 1 plus sin A by cos A. So we have cos A in both the denominators. The LCM is cos A itself. So in the numerator we have 1 minus sin A plus 1 plus sin A. Minus sin A plus sin A cancels off, 1 plus 1, 2 by cos A, which is equals to 2 sec A that is equals to the right hand side. You can use any one of the method to solve this question. There can be other methods as well, but I think this will be the easiest one, or you can use this method as well. This is also pretty easy. The third example in this chapter is tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta is equals to 1 plus sec theta cosec theta. So in this particular question, the right hand side is quite solved already, but what we need to do is we need to solve the left hand side. So we'll take the left hand side. Left hand side is tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta. Okay. In this particular question, if I take the LCM, taking LCM will only complicate this question because we do not have any square relation with tan square theta and cot square theta. Tan has square relation with sec and cot has with cosec. So instead of solving this particular thing, what we will do is we'll use the quotient formula to convert tan and cot into sin and cos. So tan theta becomes sin theta by cos theta by 1 minus cot theta becomes cos theta by sin theta plus cot is cos theta by sin theta by 1 minus sin theta by cos theta. On taking LCM in the denominator, we get sin theta. Okay, numerator's denominator goes to the denominator. So while taking LCM over here, this has 1 in the denominator. So 1 and sin theta, LCM is sin theta. Sin theta multiplies over there. Sin theta minus cos theta plus cos theta. Sin theta in the numerator's denominator goes to the denominator. On taking LCM, 1 and cos theta, the LCM is cos theta. We get cos theta minus sin theta. So this is equals to this denominator's denominator goes to the numerator. So sin square theta by cos theta sin theta minus cos theta. Okay. Next up, what we are doing is, look carefully. This is sin theta minus cos theta. Here we have cos theta minus sin theta. So in order to make them same, what we are doing is we are taking the negative sign common. On taking the minus sign common, plus becomes minus, minus becomes plus. So it becomes sin theta minus cos theta. And the minus, when we take common, it comes as a sign in between. So this goes to the numerator, cos square theta by sin theta minus cos theta. Next, we'll take 1 by sin theta minus cos theta common. We have sin square theta by cos theta minus cos square theta by sin theta. On taking LCM, we get sin cube theta minus cos cube theta by sin theta cos theta. So this is equals to 1 by sin theta minus cos theta. A cube minus b cube is equals to a minus b, a square plus ab plus b square by sin theta cos theta. Okay. This in the denominator, this is in the numerator, cancels off. this is equals to sin square theta plus cos square theta is 1 plus sin theta cos theta by sin theta cos theta. So we get 1 by sin theta cos theta plus sin theta cos theta by sin theta cos theta. We are separating sin theta cos theta in the denominators by taking this ones with 1 and ones with sin theta cos theta. So 1 by sin theta is cosec theta and 1 by cos theta is sec theta plus sin theta cos theta cancels off. We are left with 1. So this is equals to the right hand side. For those of you who do not know, a cube plus b cube is equals to a plus b, a square minus ab plus b square, and a cube minus b cube is equals to a minus b, a square plus ab plus b square. We have used this formula in our equation. Okay, the fourth example. The fourth example is 1 plus sec a by sec a is equals to sin square a by 1 minus cos a. In this question particularly, if we take one side and try to solve it, we'll get the other side, but that will get a little difficult. So what we'll do is we can take the left hand side, simplify it as much as possible, then take the right hand side and simplify it as much as possible. I'll show you both the ways. Once by taking just one side and solving it completely. Let's say we can take any side over here. Let's say I take right hand side. So right hand side we have sin square a by 1 minus cos a. Sin square a is 1 minus cos square a by 1 minus cos a. 1 minus cos square a becomes 1 plus cos a into 1 minus cos a by 1 minus cos a. So 1 minus cos a cancels off. We are left with 1 plus cos a. You can stop over here and solve the left hand side, or you can solve this as well. Say dividing numerator and denominator by cos a. So we get 1 plus cos a whole divided by cos a. In the denominator we have nothing, so that means there is 1. So 1 by cos a. So 1 by cos a is sec a plus cos a by cos a is 1 and 1 by cos a is sec a. So this is equals to our right hand side. Or you could have stopped just over here, taken the right hand side after that, solved it and found the value as 1 plus cos a. That would be a solution. Sorry, we took the right hand side. We have shown that this is equals to the left hand side. Okay. Or what we could have done is we could have taken left hand side, that is 1 plus sec a by sec a, solved it, 1 plus 1 by cos a by 1 by cos a, take the LCM over here, 1 and cos a, LCM is cos a, this becomes cos a plus 1 by 1 by cos a. This is equals to cos a plus 1 by cos a into 1 by cos a. Cos a cancels. We are left with cos A plus 1. Now what we are doing is we are taking the right hand side. Right hand side is sin square A by 1 minus cos A, that is equals to 1 minus cos square A by 1 minus cos A, which is equals to 1 plus cos A into 1 minus cos A by 1 minus cos A. So this 1 minus cos A cancels off. You are left with 1 plus cos A. Therefore, left hand side is equals to the right hand side. In this way also you can form. If you find this difficult, you can use this method to solve the question. Okay. Example 5th. So third, fourth, yeah, 5th. So in the 5th example, this is a very important example. Mark this. This is a standard question that is asked almost every time. So cos A minus sin A plus 1 by cos A plus sin A minus 1 equals to cosec A plus cot A. Okay. First of all, we'll note the right hand side, what the right hand side is. So right hand side is cosec A plus cot A. So cosec, if you convert according to the reciprocal formula, we'll get 1 by sin A, and cot, cos A by sin A. In both of this, the denominator is sin A. So over here, we'll try and convert this in terms of cosec and cot by dividing the numerator and the denominator by sin A. So we'll take the left hand side. There are a number of methods to solve this particular question. We'll deal with each of them one by one. So on taking left hand side, cos A minus sin A plus 1 by cos A plus sin A minus 1, dividing numerator and denominator by sin A. We have chosen sin A because cosec, in order to get cosec and cot, we need to divide by sin. So this is equals to cos A minus sin A plus 1 whole divided by sin A, and the denominator cos A plus sin A minus 1 whole divided by sin A. In this particular method, you will need to memorize the steps one by one. If you forget one step, then you will find it difficult to solve this question. Cos A by sin A is cot A minus sin A by sin A is 1 plus 1 by sin A is cosec A by cos A by sin A is cot A plus sin A by sin A 1 minus 1 by sin A is cosec A. Now we'll rearrange this a bit. We'll get this is equals to, if you see, the sign of cosec is plus, the sign of cot is plus, the sign of 1 is minus. What we'll do is we'll write cosec A plus cot A minus 1, and in the denominator the sign of 1 is plus, the sign of cot is plus, the sign of cosec is minus. We can either change the denominator later, or we can change the denominator now itself. We'll put 1 at first and now the remaining 2. Say minus cosec A plus cot A. Cosec was minus and cot was plus. In the next step, what we will do is we will change this 1 in terms of cosec and cot. 1 In the formula, in terms of cosec and cot, cosec square theta is 1 plus cot square theta. So cosec square theta minus cot square theta will be equals to 1. So in place of 1, we'll write cosec square theta or cosec square A minus cot square A by 1 minus cosec A plus cot A. Now A square minus B square is A plus B into A minus B. So cosec A plus cot A into cosec A minus cot A. In the denominator we have 1 minus cosec A plus cot A. This is equals to, as you can see, cosec A plus cot A comes common in both these terms. So cosec A plus cot A. Here we are left with 1 minus, in brackets we have cosec A minus cot A. Once you have one bracket in the inside, make sure you are using the square brackets on the outside by 1 minus cosec A plus cot A. This is equals to cosec A plus cot A into 1 minus cosec A minus into minus becomes plus cot A whole divided by 1 minus cosec A plus cot A. So the numerator and the denominator cancels off. This is equals to cosec A plus cot A. That is equals to the right hand side. So this is one method of solving this. The other method will be, I'll just write over here and solve that. Or we are given in the left hand side cos A minus sin A plus 1 by cos A plus sin A minus 1. Okay, let's make a small rough work here. What do we have in the right hand side is cosec A plus cot A. So cosec A plus cot A becomes 1 by sin A plus cot A becomes cos A by sin A, which is equals to 1 plus cos A by sin A. In the next step, what we will do is we will either take the numerator or the denominator. It's your choice again. You can take the numerator and multiply with both of them, multiply and divide. Or you can just take sin A and multiply and divide with the left hand side. Say we take sin A because it will be less, because it will be easier to calculate. Cos A plus cos A minus sin A plus 1 by cos A plus sin A minus 1, and we are multiplying and dividing with sin A. Now in the right hand side we should get sin A in the denominator. So what we'll do is we'll only multiply sin A with the numerator, because in the denominator we need this sin A. We'll not multiply this sin A over here. We'll multiply the sin A only that is in the numerator. If you would have taken 1 plus cos A, we would have not multiplied the numerator, we would have multiplied the denominator. Since we are taking sin A, we'll multiply the numerator and we'll leave the denominator as it is. So cos A into sin A is cos A sin A minus sin A into this thing becomes sin square A plus sin A by cos A plus sin A minus 1 in brackets, and we are multiplying with sin A. We'll not multiply this, we'll leave this as it is. In the numerator, now we'll need to make some changes. As we can see, there is a square quantity over here, sin square A. Sine square A, when we have to convert this using square relation, what we can do is we can write sine A as 1 minus cos square A by cos A plus sine A minus 1 into sine A. This is equals to, in this and in this we can take sine A common, will be left with cos A plus 1 minus this 1 minus cos square A becomes 1 plus cos A into 1 minus cos A divided by, we have cos A plus sine A minus 1 into sine A. Now this and this term comes common in the numerator. So we have 1 plus cos A as common. Here we are left with sine A minus, in brackets we have 1 minus cos A. Again, as we have one bracket on the outside, we will make a square bracket on the outside divided by cos A plus sine A minus 1 into sine A. So 1 plus cos A sine A minus 1, minus into minus is plus cos A, and we'll rearrange the denominator as according to the numerator. Sine A is positive, we can also write in the first. Then we have minus 1, we have minus 1. Cos A we are taking to the end. Cos A sine is positive, so we are taking plus cos A into sine A. We'll cancel this off. We are getting 1 plus cos A by sine A. 1 plus cos A by sine A. 1 by sine A is cosec A plus cos A by sine A becomes cot A. So this is equals to the right hand side. You can prove using this method as well. This method is also correct. This method is also correct. In both the methods, you will need to remember the steps. In the second method, you can take the numerator, you can multiply and divide with the numerator as well. But keep the numerator as it is and multiply the denominator with these terms. If you are taking 1 plus cos A. So these are the two methods. In these two methods, this becomes your third method. I'm not solving that. You can try it on your own with the numerator. Next question. Example 6. Root under of 1 plus sine A by 1 minus sine A is equals to sec A plus tan A. Whenever you have root on one side, we always need to take that side and solve it. We are taking left hand side, we are getting 1 plus sine A by 1 minus sine A. We'll try to remove the denominator. In trying to remove the denominator, what we need to do is we need to multiply and divide by 1 plus sine A. Multiplying and dividing by 1 plus sine A. Why? Because 1 plus sine A into 1 minus sine A will become 1 minus sine square A, which will convert to cos square A. And make sure you are taking this multiplication and division inside the root itself, which is equals to root under of 1 plus sine A whole square by 1 minus sine square A. So this equals to root under of 1 plus sine A whole square by 1 minus sine square A is cos square A. 1 plus sine A whole square, the root becomes 1 plus sine A by the square root of cos square A is cos A. Now taking cos A with once with 1 and once with sine A, 1 by cos A becomes sec A and sine A by cos A becomes tan A. This is equals to the right hand side. number 7. Sin theta minus 2 sin cube theta by 2 cos cube theta minus cos theta is equals to tan theta. Again, definitely we need to take the left hand side and work with this over here. In the left hand side, we are taking sin theta common in the numerator. We are getting 1 minus 2 sin square theta. In the denominator, we are taking cos theta common. We are getting 2 cos square theta minus 1. So after this, as you can see, in the numerator we have sin square theta, in the denominator we have cos square theta. So you'll change any one of these two. You can either change sin square theta into 1 minus cos square theta, or you may change in the denominator cos square theta into 1 minus sin square theta. Sin theta by cos theta becomes tan theta. Let's say we change the numerator, we get 1 minus 2 into sin square theta is 1 minus cos square theta by this is 2 cos square theta minus 1. Don't change both of them, you will get stuck again. Change any one of the numerator or the denominator. So tan theta 1 minus 2 into 1 is 2, minus into minus plus 2 cos square theta by 2 cos square theta minus 1. So this is equals to tan theta. In the numerator we have 2 cos square theta. 1 minus 2 is minus 1 by 2 cos square theta minus 1. So this cancels off. We have tan theta. This is equals to the right hand side. Example 8. I am solving a number of questions over here so that you do not face much difficulty in this portion. Sin A plus cosec A whole square plus cos A plus sec A whole square is equals to 7 plus tan square A plus cot square A. So say we take the left hand side and solve it. So left hand side is equals to sin A plus cosec A whole square plus cos A plus sec A whole square. Some questions may appear to be difficult on the outside, but actually you will find they are pretty easy. On solving this, a plus b whole square is a square plus 2ab plus b square. Over here same again, cos square a plus 2 cos a sec a plus sec square a. So sin square a plus cos square a becomes 1. So we'll take them together. Plus 2 sin a into cosec a is basically 1 by sin a. Then we have plus cosec square a plus 2 cos a into sec a. Sec a becomes 1 by cos a plus sec square a. Sin square a plus cos square a is 1. Sin a cancel. Here cos a cancel. Plus 2 plus cosec square a plus 2 plus sec square a. So 1 plus 2 becomes 5. Cosec square a is equals to 1 plus cot square a. In the right hand side, as you can see, we need to find in terms of tan square a and cot square a. So we'll convert cosec square a into 1 plus cot square a and sec square a into 1 plus tan square a. So 5 plus 1 we have 7 plus cot square a plus tan square a. This is equals to the right hand side. Example 9. Cosec A minus sin A into sec A minus cos A. This is equals to 1 by tan A plus cot A. Okay. Here again, if you see, you have work to do on the left hand side as well as you have work to do on the right hand side. In such questions, we'll take left hand side separately and again right hand side separately, and when we solve them, we should get the same result, simplified result. So in solution, we are taking first the left hand side. Left hand side is cosec A minus sin A into sec A minus cos A. So this is equals to 1 by sin A minus sin A into 1 by cos A minus cos A. So this equals to, on taking LCM, 1 minus sin square A by sin A into 1 minus cos square A by cos A. So 1 minus sin square A is cos square A by sin A into 1 minus cos square A is sin square A by cos A. So cos A and the square cancels off, sin A and the square cancels off. We are left with cos A into sin A. Now we'll take the right hand side. Right hand side is 1 by tan A plus cot A. That is equals to, we'll convert them in terms of sin and cos. Tan A is sin A by cos A and cot A is cos A by sin A. So this is equals to, on taking LCM in the denominator, this becomes sin square A plus cos square A divided by sin A cos A. Sin A cos A goes to the numerator and sin square A plus cos square A is 1. Therefore, left hand side is equals to the right hand side. Number 10. 1 plus tan square A by 1 plus cot square A is equals to, say, tan square A. So left hand side, we are taking 1 plus tan square A by 1 plus cot square A. So 1 plus tan square A is basically cosec square A by 1 plus cot square A is, 1 plus tan square A is sec square A, 1 plus cot square A is cosec square A. Sec square becomes 1 by cos square A and cosec becomes 1 by sin square A. Now we are left with sin square A by cos square A, or we can write sin A by cos A whole square. So this becomes tan square A. You might also sometimes be given in the same question as, say, this and this is equals to, say, 1 minus tan A by 1 minus cot A whole square. So when you have three terms like this, there is nothing to panic. Once you took the first term, solved it, you got this as tan square A. Now what you need to do is, you need to take another and show this as tan square A. So if these two are equal and this two is equal, so this will obviously be equals to this. Say I take the right hand side. This is equals to 1 minus tan A by 1 minus cot A whole square. I am taking this portion over here to solve this. So this is equals to 1 minus 2 tan A plus tan square A by 1 minus 2 cot A plus cot square A. So this will be equals to 1 plus tan square A is sec square A minus 2 tan A by 1 plus cot square A is cosec square A minus 2 cot A.